Hello everyone, my name is Philip Mittal and today I'm going to be talking about my project that is multi-modal plugins for media control. Now, starting with the main talking points that we're going to be discussing today. The first one being the problem statement. Then I'm going to be talking about multimodality, the available work that has already been done in this or similar kind of fields. Then the solution and the algorithm that I've used to solve the problem stated above. And after that, I'm going to be talking a little bit about speech recognition and gesture recognition. And finally, I'm going to conclude this presentation with my demo of the software. Now, so the problem statement here was to implement a multimodal media player. I'm going to be talking about multimodality in the coming slides. But for now, let's just go with the term. And more so, even in working with the multimodal media player, I want to develop open source speech and gesture recognition libraries for customizable applications. That means I'm creating such libraries so that next time, if user demands certain kinds of application specific to his or her needs, it can easily be integrated into such platforms. Now, what is multimodality? As the term suggests, it's modality, that is means of communications or expression of communication via different means. So this kind of communication practice generally involves different parts such as audio, linguistic, visual, or gestures. Basically a more seamless way of interacting with the computer rather than having discrete parts such as a keyboard or a mouse. The advantages of multimodality can be, we have again reduced dependence on discrete inputs, and another part is seamless human-computer interaction. That means as we are moving towards devices that should require less space, should be more smart, and should have better interaction with the user, I believe the keyboard and mouse are soon gonna lose their status in the current computing technology. So the available work. Now, in this project, I have specifically targeted two parts, that is the gesture recognition technology and the speech recognition technology. Now, to talk about gesture recognition, I would say that the current form of technology that's available in the market starts with the complex hardware choices. That means you need to have special equipment if you want to work with gestures. Examples of such can be a Kinect camera or a Tobii eye tracker or Intel RealSense camera. Now, the problem with that is, since these are licensed softwares, they are not easy to get and don't come as a part of the standard package. Apart from that, the libraries that come inbuilt with these kind of devices are very limited in use and are generally designed for commercial uses in certain applications. And it's kind of hard to tweak with these applications to suit a user's need. Secondly, the work in the speech recognition technology is almost non-existing. That means the best you can see in speech recognition is the personal assistants in your phones, such as Siri or Google Voice, and now Amazon Echo has been catching up. But apart from that, not much work has been done into speech recognition, and a big reason for that is there are not many language models that support this kind of software, since different people have different kind of accents or different way of their speech. It is kind of very hard to develop a system that can be unified with all these approaches. And lastly, multimodal interfaces. I haven't come across any big project or any idea that is currently moving forward in this direction, which is why I thought it might be a good start to work in this direction and maybe later on develop a technology or develop a system which can again serve to different kind of needs of users or start with different applications. So to solve this problem, to develop a multimodal media I wrote the code into two major components, that is the speech component and the gesture component. And while doing so, I made sure that instead of using time sharing applications, I use independent entities. Now, the best part about using independent entities is that it offers modularity. The systems are not dependent on their turns when the user is giving the input commands. And in future, if there is a need to add more functions or different kind of modalities, it can be easily integrated without affecting the rest of the system. And the last part of this solution was key press simulation. Now, there was an option to include the functions straight away into the library of the media player. However, in case there is a need to change to a different application, let's say a notepad or probably a game, so instead of making those libraries again and again and rewriting into the main code, it is better to start with the key press simulation and see how that works. Now, the solution algorithm, as you can see, it takes a user voice input and the gesture input at the same time, and sends the recorded input into the two functions, that is the speech recognition function and the gesture recognition function, which I'll be discussing in the future slides. And after that, the code checks for the match with the existing commands, that is, if it's a play or pause, or if it's a volume up or a volume down command. And if the command matches, then it invokes the keyboard event function that simulates a key press. Otherwise, it goes back to reading the input from the user. Now, as you can see, there are two functions or two boxes that talk about the pre-existing commands into the software code. The advantage of using such kind of system is that in future maybe I need to add more functionality to my same system, let's say increase the speed or probably change the size of the video. So I won't have to write the whole code again and again. I can just add a separate if-else condition and move on with the system without affecting much of the code. To talk about speech recognition system, on the right side, you can see a basic small piece of code that starts with the recognizer function that creates an instance of the already existing speech recognition library in the Python module. After that, the source is selected as a microphone. It can be any active microphone. In this case, we have used a normal inline mic instead of the laptop's original microphone, so as to avoid background noises getting into the system. And after that, there is a buffer that collects the recognized speech from the API. In this case, we have used Google API rather than many other technologies available. And after that, the match is performed, and as you can see, there are only two cases. Either it's a volume up or a volume down command, and then it returns that kind of list to the keyboard event function. And after that, it calls itself. So the system goes into an infinite loop and keeps waiting for the input until the program is closed. So while working with the speech recognition, these are the different technologies that I tested, including Microsoft Cortana, Siemens Sphinx, Speech Notes, Google Speech API. Now, most of them offer a very low or medium accuracy and are not very easy to integrate, which is why I finally shortlisted the Google Speech API, which comes in as an inbuilt library for Python speech recognition and offers a relatively high accuracy as compared to the other system, except for Microsoft Cortana, of course, but it cannot be integrated. It's not open source as of now. Moving on to the results, as you can see on the left side, the speech recognition system, all the works very well. The volume up and volume down events are generated at a very good accuracy, but overall there are chances when it might not read the exact command. And on the right side, there is a huge possibility, or there are a few commands which, if you try speaking in a different accent or a different dialect, it might not be able to recognize at all, and it shows an unknown value error. Now, recognition, let's talk about a little bit on the gesture recognition part. So the video capture function opens the camera that has been selected. The value 0 in the video capture function basically means the inbuilt laptop camera, and after that you can select any kind of input source and work with it. After that, the data is fed into the rectangular source, rectangular window that I'm going to be talking about in the next few slides. Post that, the math library is used to calculate the number of defects in each instance of the image that has been recorded. And once the defects have been counted, then it initiates the command sequence. So here we have chosen only two parts, that is play and pause. So if there are 5 defects in the window, the system is going to give you a pause, and if there are 3 defects in the window, they're going to be showing you a play command. So here are the outputs. As you can see, in the right hand side, the five defects are being detected by the contour plot, and this leads to a pause. And similarly, the 3 defect gesture or the OK gesture here runs the video as per the. And finally, to see the results, the system is almost 100% accurate. As you can see, the gestures were correctly recognized, and I'm going to be showing that in the demo video next. But the overall accuracy of the system was brilliant, and I believe more work can be done into it to have motion gestures rather than just static gestures, and maybe read more frames at the same time, and make the system work even in a better way. So now see how the system performed overall, how the software performed. So I'm going to be running this demo video, and let's see. Volume up. So as you can see, if I'm saying volume up or if I'm making the gestures, the volume left hand side is taking that gestures, making the wheels volume down active, and executing the same commands. So the volume command, the volume up and down, volume or up, the play and pause can be seen on the top right corner of the VLC media player. On the volume bottom left of your screen, you can see the actual voice commands that are being taken into account, their output as to whether it's reading perfectly fine or not. And in the middle down section, the play and pause commands from the gestures are being recorded, so as to keep a track whether the system is performing as per the required limits or not. Volume up. Volume up. Volume down. Volume down. Volume up. Volume up. So this was the demo of actual working of the code that I've written, and I believe in future more modalities can be added to the same, and can be packaged into a better GUI as compared to the normal command line interface that is being going on in the background. So overall, if I believe that more work should be done in this direction, more features should be explored in the multimodality part, and it can work well with the future generation of computers. So this was my project on multimodal media player plugins. I hope you liked it. Thank you everyone for watching.